So I've created a bit more room here and recopied our results from steps 1 and 2 so that we can refer back to those. And let's move on to step 3. In step 3, we're going to plug our particular solution yp into the DE. And in doing this, we are trying to find the values of these numbers a and b that are the coefficients of our particular solution. So before we can put yp into the DE, we need to know what its derivatives look like. So I'm going to recopy yp. Yp prime would look like this: a cos x minus b sine x, and yp double prime minus a sine x minus b cos x. So now we're going to plug into our DE, and we might find it helpful just to have the DE recopied here for clarity so that we can see what we're plugging into. So first thing we're going to write down is yp double prime. So in plugging yp into the DE, when we see this y double prime, we want to replace it with yp double prime. So we're going to have minus a sine x minus b cos x. Okay, and then moving on, we've got minus 8y prime. So when we run into this y prime term here, we're going to replace that with yp prime, which is a cos x minus b sine x. Okay, and then continuing to plug in, we've got plus 15 times y. So we're going to replace that y with the yp. We'd have a sine x plus b cos x. And continuing our plug-in, we're saying that's equal to 65 sine x. Perfect, so we've plugged in there. So we're going to expand and collect our like terms. So I would just be aware of the coefficients here. As we distribute this negative 8, our coefficients are going to be negative 8a and positive 8b. So we can see we've got the correct coefficients here. And then over our last set of brackets on the right side, we should have coefficients 15a and 15b. Okay, so that was the expansion part. Now we want to collect like terms. So the types of like terms that we've got, there are 2 of them. We've got sine x terms and we've got cos x terms. So let's deal with the sine x terms first. How many sine x's do we have? So we've got minus a. From the 4th term, we've got plus 8b. And then we've got another plus 15a. So if you like, you could cross off those terms as you use them. Minus a plus 8b plus 15a, and if we wanted to simplify that coefficient, we could say that's 14a plus 8b. So that's how many sine x terms we've got. So let's do the same thing with cos x. How many have we got? We've got minus b, we've got minus 8a, and we've got plus 15b. Okay, so if we wanted to simplify that, we could say minus 8a plus 14b is how many cos x terms we've got. Okay, and over on the right side, that is equal to 65 sine x, but probably even better to say that 65 sine x plus 0 cos x. And we'll see in a minute why it's important to actually be clear here that cos x has coefficient 0. So I've just recopied our most recent step over here, and let's create some more room to finish up. So we're continuing step 3. We're trying to figure out these values of a and b, and the way we're going to do that is we're now going to match up the coefficients on both sides of this equation. So since we've got an equation, we should have the same number of sine x terms on both sides of the equation, and we should have the same number of cos x terms on both sides of the equation. So we're going to be able to match up the coefficients. We're going to be able to say 14a plus 8b is going to have to be equal to 65. So that gives us one equation. And if we look at the cos x terms, we must have the same number of cos x terms on both sides. So we can say this coefficient must be equal to 0. Minus 8a plus 14b must equal 0. So let's call these equation 1 and equation 2. We'll go through and solve them for a and b. So let's try to eliminate a. Let's multiply equation 1 by 8 and equation 2 by 14, and that way we'll get rid of the a's here. So multiplying equation 1 by 8, we get 112a plus 64b is equal to 520. Multiplying equation 2 by 14, we get minus 112a plus 196b is equal to 0. Okay, so by adding these two equations together then, the a's will be gone. There's no a's, so we've eliminated those, and we're getting 260b is equal to 520. So that's great. Now we can solve for b. Dividing through by 260, b is equal to 2. So now we can take this information that b is 2, we can plug it back into either equation. I would suggest equation 2, and we'll be able to get our value of a. So looking back here at equation 2 and plugging in, we'd have minus 8a plus, we're subbing in b equal 2, so our next term is going to be 28 is equal to 0. That tells us negative 8a is equal to negative 28. So a is equal to negative 28 over negative 8. Or if we divide top and bottom here by negative 4, 7 over 2 would be a nicer way of expressing a. Alright, so finally we're at the end of step 3. Remember that originally we said that yp had the form a sine x plus b cos x. Well, now we can be specific about what those coefficients are. A is 7/2, so 7/2 sine x, plus b is 2, so we're going to add on 2 cos x. So I'll just label this part step 3 so we know we're done with that, and 2 more very short steps to go. So in step 4, we're going to create our general solution, y, and we're going to do that just by adding yc and yp together. So we'll be consulting back with our work from step 1, that was over here, and we'll be consulting our work from step 3, which was down here. So y is equal to, copying down c1 or yc, yc is c1 e to the 3x plus c2 e to the 5x, and then adding on our particular solution, plus 7/2 sine x plus 2 cos x. All right, and this is what's called the general solution to the DE. So notice that the first part of the solution has unknown constants as the coefficients here. So these unknown coefficients here make sure that we're capturing all possible solutions to the DE. Whereas notice that the second part here, the part coming from YP, has very specific coefficients. And these specific coefficients are required to make sure that the right side comes out exactly to what we want it to be. So if you do anything to these coefficients, including even multiplying them by a constant, you're going to change the right side in a way that's going to make this incorrect. So unfortunately, you can't multiply these through by 2 or change them in any way. So I mentioned we were doing a 5-step procedure. The 5th step is to deal with any initial conditions that might be given. Initial conditions are always dealt with at the end of the problem after we've written down the general solution. Now, fortunately for us, there were no initial conditions in this problem, so we don't have to worry about that. So that is our 5-step procedure done. Thanks for watching, and we'll see you in the next video.